port of Keelung was the largest port in Taiwan during the Japanese colonial period and served as the main trade port in the early days of Japanese rule. At that time, the population was approximately 7,000 people. As trade grew, the population increased significantly, leading to increased demand for drinking water, military use, and water supply for ships. The construction of a waterworks was urgently needed. In 1896, British engineer William Burton was hired to serve as a sanitation works consultant in Taiwan. His primary objective was to identify a clean and stable headwater for the region. In the same year, he conducted headwater investigations along with his student, Hamano Yashiro. Their research took them to various locations, including Tamsui, Keelung, Taipei, Taichung, Tainan, and Penghu. Simultaneously, to gather references from neighboring countries, Burton traveled to Shanghai, Hong Kong, and Singapore in 1897 to conduct sanitation and waterworks surveys. In 1896, he presented a sanitation works investigation report, a Keelung waterworks investigation report, and in 1897, he submitted a water quality test report. Keelung is surrounded by mountains on 3 sides, and although there are several small streams in the mountains, their drainage basins are narrow, and the water supply is insufficient. In 1897, it was discovered that the upper reaches of the Shishir River and Dongshu River, tributaries of the Keelung River, had abundant water flow and excellent water quality due to dense forests. The upper reaches of the Shishir River were chosen as the headwater, and in 1898, a weir was constructed at the confluence of Dongshu River and Shishir River, known as Nuanyuan River. To address the urgent water supply issue in Keelung at that time, untreated raw water was initially supplied downstream using natural gravity flow. The Keelung River had abundant water but had a winding course and was prone to flooding, making it unsuitable as a headwater. Therefore, it was decided to use the Shishir River, a tributary of the Keelung River, as the headwater. Construction of the Keelung waterworks began in 1898, with the first were built in 1899 on the upper reaches of the Shishir River. Water intake points and iron pipes were installed, and water was directly conveyed via the iron pipes by natural gravity to the number 1 well at the highest point of the water purification station. Additionally, to raise the water level, a second weir was built further upstream on the Nuanyuan River, and water intake wells and pump room were installed to pump water to the number 1 well at the water purification station. The Keelung waterworks took 4 years to complete and was finished in 1902. It was the second water supply facility in Taiwan, following the completion of the Tamsui Hobei Waterworks in 1899. The Keelung waterworks utilized river water as its source, and because the water contained impurities and microorganisms, it required water purification facilities. It was Taiwan's first water supply system with a complete water purification facility and represented a significant early public health project during the Japanese colonial period. The facilities of the Keelung waterworks included the following components: weir, water intake point, intake wells, pump room, number 1 well, coagulation basin, sedimentation tank, number 2 well, sand filters, number 3 well, clear water reservoir, sand washing area, warehouse, and office. The water supply process of the Keelung waterworks started at the first weir, where water was taken. It was then conveyed through iron pipes by natural gravity to the highest point of the water purification station at number 1 well. Simultaneously, water from the Nuanyuan River second weir was introduced into intake wells via 350 mm iron pipes, utilizing osmotic pressure. From there, water was pumped from the intake wells to the highest point at number 1 well at the water purification station to equalize water quality. Subsequently, it flowed downstream to the sedimentation tank by gravity. In the sedimentation tank, larger particles and impurities settled out. The water then entered number 2 well. The octagon well is a historic building with a circular well inside and an octagonal exterior. It contains water pipes that distributed water to 2 slow sand filters. During the Japanese colonial period, slow sand filters were commonly used for filtration. These tanks were filled with layers of sand, gravel, or crushed stones, and the properties, size, and thickness of the filter bed were closely related to the removal of bacteria and particles. The filtration process involves the raw water flowing from the distribution well into the slow filtration tanks. The raw water passes through a primary sand filter layer of approximately 1 meter thick and then through the lower layer containing pebbles and crushed stones, which serves to block sand particles, allowing clean water to flow into the drainage pipe. To prevent clogging in the sand bed, sand scraping and turning operations were conducted approximately every 1 to 2 months, followed by exposure to sunlight to achieve algae removal and disinfection. The filtered water from this process then flowed into the sand filter well through the drain pipe and subsequently entered the clear water reservoir. The water from the clear water reservoir was sent through pipelines to a distribution reservoir and then transported along the western line of Taiwan Railway to Badu. It crossed the Keelung River via the Badu Bridge and reached the Keelung port area, providing water to approximately 30,000 residents in Keelung at that time, including for military and maritime use. The primary role of the Headwater Conservation Forest is soil and water conservation, as well as improving water quality. When Burton conducted the investigation for the Keelung Waterworks, he found that the watersheds above the Dongsha River and Shisha River valleys, the headwater for the Nuanyuan Water Purification Station, had steep terrain and fragile geology. In his report, he recommended the establishment of a headwater conservation forest. In 1904, Nuanyuan became the location of Taiwan's first headwater conservation forest. After the completion of the Western Line in 1908, the population of Keelung increased to about 40,000 people. To increase the water supply, the manual water pump was replaced with coal-fired steam-powered pumping machinery in 1908, with a pipe diameter of 4 inches. The pump room was also renovated, and a chimney was added to the roof, making it the second-generation pump room. In 1914, as part of the transformation of the distribution system of the Keelung Waterworks, German-made steel water pipes with an inner diameter of about 36 centimeters were installed on both sides of the wooden sleepers on the Badu Bridge. These pipes conveyed water through the Ziziling Tunnel to the Keelung urban area. In 1915, in response to population growth, an additional coal-fired pumping unit with a 5-inch pipe diameter was purchased. In 1917, clear water reservoirs, clear water wells, and sand filter wells were constructed. In 1918, the first weir was raised in height to increase water storage capacity, serving the water needs of approximately 50,000 people in the Keelung urban area. After the completion of the Keelung Waterworks in 1902, it initially had 1 sedimentation tank and 2 slow sand filters. It was subsequently expanded 4 times, reaching a capacity of 2 sedimentation tanks and 8 slow sand filters. In 1923, the Shisha Reservoir was constructed at the confluence of the Nanzi River and Aon River in the upper reaches of the Shisha River. It was completed in 1926 and was Taiwan's first reservoir specifically for domestic water supply. The Shisha Reservoir, also known as the Nuanyuan Reservoir, is located in Zishikeng, Nuanyuan District, Keelung City, approximately 5.2 kilometers from Port of Keelung. It has an effective storage capacity of 400,000 cubic meters, which increased to 550,000 cubic meters by 2021. Currently, it serves as a backup reservoir for the Xinshan Reservoir. Since its completion, it has been responsible for supplying water for domestic and industrial use to the residents of Keelung City. There is a Keelung Waterworks Reservoir monument on the reservoir, symbolizing the Shisha Reservoir as a milestone in Taiwan's dedicated domestic water supply reservoirs. At the confluence of the Shisha River and Dongsha River, there is a unique twin Tudagong temple in Taiwan. Inside the temple, there are 2 Tudagong statues, Fuxing Earth God and Fuder Earth God. Originally, these two Tutagong statues were located separately in the Nuanyuan Water Purification Station and the Shishir Reservoir. However, due to the construction of the Keelung Waterworks and the Shishir Reservoir, they were relocated to this temple. They now watch over the Shishir River and Dongshir River respectively, providing dual protection for the area and offering blessings to those who visit the temple. In 1924, the third-generation pump room was constructed to accommodate the shift from steam-powered pumps to diesel pumps. It also served as a replacement for the original wooden roof structure, which was prone to termite damage. This building still exists today as a historical monument.
所以现在目前我们看到有一个那个有巴洛克式风格的一个建筑物，就是胖虎间。那里面还有一个西德德国进口的一个发动机跟抽水机。那这个是工业的遗迹啦，工业的那个机具，它很有那个历史价值。对啊，那这些已经退役了。
The German MWM company provided the generators and pumping machinery, and they are still in operation today. This century-old pump room features Baroque architecture with a flat roof design. Its structure and openings are adorned with a rustic terrazzo band, and the corners are emphasized with decorative columns. The design is simple yet distinct, with appropriate color schemes, making it highly valuable for preservation. 1896, Keelung Sanitation Survey. 1898, commencement of the first phase of the Keelung Waterworks project. Construction of the Nuanyuan River Weir. 1899, expansion of Keelung Port into a major trading port. Commencement of the second phase of the Keelung Waterworks project. Construction of the Shishir First Weir. Heightening of the Shishir Second Weir. Construction of the first generation pump room. 1902, completion of the Keelung Waterworks. 1904, establishment of headwater conservation forests. 1908, first expansion of the Keelung Waterworks. Construction of the second generation pump room. 1917, second expansion of the Keelung Waterworks. 1923, third expansion of the Keelung Waterworks. Start of construction of the Shishir Reservoir. 1924, construction of the third generation pump room. 1926, completion of the Shishir Reservoir. The Nuanyuan Water Purification Station, planned and constructed during the Japanese colonial period, was a pioneer in Taiwan's water treatment facilities, setting numerous records. It was Taiwan's first water supply system with complete modern water treatment equipment, the first waterworks with water quality testing reports, the first headwater conservation forest, the first century-old pump room, and the first reservoir dedicated to domestic water supply. Taiwan ranks among the top in the world in terms of rainfall, but is the 18th most water-scarce country globally. Yet, it offers one of the cheapest water rates in the world. As we enjoy clean tap water, we should remember on the efforts and contributions of our predecessors in public water supply development.